guys, we are starting on, we're still graphing rational functions in section 8.3 like we did in 8.2, but these are going to be higher degree functions. So our learning target, graph rational functions with higher degree polynomials. So remember, a rational function is just a fraction with two polynomials, one in the numerator and one in the denominator. And in case you've forgotten what the degree is, the degree of a polynomial is the highest exponent. So you're going to be looking at the exponents. And we've got some steps that we need to go through for graphing these. And a lot of these steps are common for any graphs. A few of these will be a little different. But in any graph, you want to find the x-intercepts. And in a rational function, you find the x-intercepts by setting the numerator equal to 0 and solving. And we're going to solve for x. Alright, now you also in any graph want to find the y-intercept. And we're going to do this like we always do in any graph by plugging in x equals 0. Okay? Alright, and we're going to go through all these steps together. Alright, so then after we find the x and y intercepts, we need to find the vertical asymptote. So the rational functions will have vertical and horizontal asymptotes. They don't always have a horizontal asymptote, but a lot of them will. And to find the vertical asymptote, you're going to set the denominator because remember, you can't divide by 0. We set it equal to 0 and solve for x. This will tell us where the vertical asymptotes are. Okay, all right. Now, our horizontal asymptotes are going to be a little more complicated this time. They have a set of rules, and to state these rules, I am going to let the degree of the numerator be the letter m. Okay, so the degree of the numerator, remember that's the highest exponent. I'm going to let m stand for the degree of the numerator. And I'm going to let the degree of the denominator be represented by an n. Okay, so I have three rules. If m is less than n, so the degree of the numerator is smaller than the degree of the denominator, then y equals 0 is the horizontal asymptote. Okay? If they equal each other, then the horizontal asymptote is the fraction of the leading coefficients. That sounds complicated, but it just means the numbers in front, the leading coefficients, are just the numbers in front of both polynomials. And I'll show you what that looks like in one of our examples. And the last case, if n is greater than n, so the degree of the numerator is bigger than the degree of the denominator, then there's no horizontal asymptote. We don't have very many of these kind of graphs, and I don't think you have any in your homework with this. You might have some in college algebra. Okay, now you're going to have to plug in some other points. So you're going to pick some x values. Between, sorry, that's an E, between the vertical asymptotes. Okay, and I'll show you what I mean on that too. You're going to think of your graph as divided along the vertical asymptotes, and you're going to pick x values on either side of those asymptotes. Alright, so let's go through these steps with the graph. We're going to graph y equals x squared minus 9 over x squared minus 4. What you want to do first is you want to factor anything that's possible to factor, because it's going to help you see all these different things. So remember, this is a squared minus b squared, which factors into a plus b times a minus b. Both of these will actually factor that way. So remember to take the square root of both of them to get your a and b values. Alright, so the first thing we're going to do is our x-intercepts. And those are the zeros of the numerator. So since I already have this factored, it's real easy to find those. We would get x equals negative 3 and x equals positive 3 if I set each one of those factors equal to 0. Okay, now let's find the y-intercept by plugging in 0 for x. Alright, so we would get 3 times negative 3 over 2 times negative 2. So that'd be negative 9 over negative 4. And that'd be positive, and I'm going to make it a decimal, 2.3, so I can put it on my graph. Alright, now we're ready for the vertical asymptote, and we're going to set the denominator equal to 0 to get the vertical asymptotes. So we get 2, one at negative 2, and one at positive 2. Alright, now here's your first example of how to do the horizontal asymptote. The degree is the highest exponent, m is 2 and n is 2. They're both 2. So this is the second case where they equal each other. And the leading coefficient in both the numerator and the denominator is 1. So you would get 1 over 1. Those are the leading coefficients, and that would just give me a horizontal asymptote at y equals 1. Okay, let's start our graph, and then we'll know what other x values we need to plug in. Alright, x-intercepts. Make sure to get all this information on your graphs because it's very vital to making an accurate graph. Alright, x-intercept at positive 3 and negative 3. A y-intercept on the y-axis of a little bit more than 2. Okay, and then vertical asymptotes at negative 2 and positive 2. You'll never cross a vertical, but sometimes you will cross a horizontal, and at 1. Oftentimes this piece in the center is a parabola, sometimes it's a sideways S, and then these branches are just going to follow, just like we did yesterday, follow these asymptotes. So really, since we have a point over here, we can already make our branches on this side of the asymptote, and this side we're going to follow those asymptotes. But we need to figure out what's happening in the center here. So I'm going to plug in x equals 1 and x equals negative 1. Alright, so let's see what happens. I get 1 plus 3, 1 minus 3, 1 plus 2, and 1 minus 2. Alright, so I'd have 4 times negative 2, and I'd have 3 times negative 1. And so that would give me 8/3, positive 8/3. Which is about 2.7. Oh, and if I do negative 1, I'd get negative 1 plus 3, negative 1 minus 3, negative 1 plus 2, negative 1 minus 2. Alright, so I'd get 2 times negative 4, and I'm going to get 1 times negative 3. So I end up with the same thing of positive 2.7. Okay, so a little bit higher than the 2.3 that I had, but still under 3. And so this piece in the center is going to be a parabola. Alright, so we are going to try one more graph here and go through the same steps again that we just did. And this will be the end of 8.3 after we graph one more. Alright, so we're going to graph this rational function. We can factor the denominator again. The numerator we can't, so we'll just leave it, but this factors into x plus 4 times x minus 4. Alright, x-intercepts, numerator equal to 0. The more times you do these steps, the more you'll remember each one, and it won't be so hard to remember. Alright, if x squared equals 0, then we just have an x-intercept of 0. For the y-intercept, remember you plug in x equals 0. So I'd plug in 0 there and 0 here. And when I multiply by 0, I just get 0. And then when I divide 0 by anything, I also just get 0. So this is going to give us a point at 0, 0. Alright, vertical asymptote, I set the denominator equal to 0. Okay, so I get 2 vertical asymptotes, one at negative 4 and one at positive 4. Horizontal asymptote is going to be like the last one. The degrees are both 2. So we make a fraction of the leading coefficient, which would be 3 over 1. And that just comes out to be 3. And let's start our graph and we'll see if we need to make any other, plug in any other values for x. Alright. Okay, the x and the y-intercept are here at 0, 0. Vertical asymptotes at positive 4 and at negative 4. Horizontal asymptote at positive 3. Alright, I don't have any points to the right of this vertical asymptote or to the left, so I will need to pick some points to plug in here. and I need to know what's happening here, is if it's a parabola. And so let's see, let's plug in -5, -1, +1, and +5 here, and we'll see what happens. When I plug in -5, and remember I'm always plugging in for x, I get 8.3. When I plug in -1, I get -0.2. And these are symmetric, meaning the values are going to be the same. I'm not showing the work here, but you guys know that I'm plugging these values in for x and calculating the outputs. All right, -5, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So we're up here. So I know this branch is going to follow these asymptotes. +5 is at the same position, following the asymptotes. -1, and it's just barely below on both sides here at -0.2. So this time it's like a parabola opening down. All right, so that's a little bit more about graphing rational functions.